instrumentation and control, we had got two parts. First part is instrumentation, the second part is control. So basically instrumentation is done for to do know about the parameters that what are our control parameters, what is the reading of our control parameters, and control is done basically to know about your system, how our system is going to respond. As I told you that in control we had different types of controller. I think you are already quite familiar with the subject of control. Yeah. In control we had got different types of control system like proportion controller, integral controller, proportion integral dynamic controller. But to tune them into a proper way is also required. And once you had got the tuning, then you also need to know about the response of our system to certain input. Basically, you know about your system that let's suppose I am going to operate this system in these conditions. Let's suppose you want that I want to operate it in some sinusoidal conditions. You had got different types of systems where, like if you talk about a nuclear reactor, so it is a very sophisticated system. So in a nuclear reactor, if there is a very small change, so it can multiply by billions and you can end up in a disaster. So we need to have a very sophisticated control system. And how we are going to say that how we are going to control our system is basically by frequency. One is the control you are doing either using proportion controller, PID controller, depending upon your application. If it is a very simple application, then you just use proportion controller, which is used for on-off controller. If you had got if there is some overshoot and you want to take out this overshoot, then you can use introduce some differential as well. And if you say that okay, this system continue to oscillate in this time, then you use a PI controller. So it's different types of configuration. And then to know about the system that how it is going to respond is basically frequency response. Frequency response is the ability of a system to respond to certain input. In this we are going to respond to a certain input. In this system we had got configuration that is tank A and tank B. Yeah. So we are introducing a sinusoidal signal, and how we are introducing this sinusoidal signal? We are introducing sinusoidal signal to a pressure manometer which is coupled to a sine wave generator. Yeah. And what is the function of sine wave generator? The function of sine wave generator is basically to convert this pressure signal to voltage signal, and this voltage signal into sinusoidal signal. Yeah. So you are getting a pressure crest and trough. As I draw it here, let's suppose it will go first to 0 mm of Hg, then it will go to 10 mm of Hg. So it's going like this. It's going like sinusoidal signal. This is the airflow is coming. The airflow we are recording through channel 1 here, and how this is coming, this is basically coming on the oscillographer here, and how we are going getting the output is also getting on the oscillographer, and it is through channel 2 here. And whenever we introduce so for a very sophisticated system, if the system is very sophisticated, so if there is certain temperature, let's suppose I say that if it is a step input, if the temperature goes from 50 to 60 degrees centigrade, then if it is a very sophisticated system, so within microsecond it will respond to this input. So we want to know that how our system is going to respond to this sinusoidal input. On what parameters it depends? It depends upon the frequency. Here it depends upon your controller. On all these parameters it depends. But here in what we are interested in? We are interested in our output. How my output is coming, how fastly it is coming. So if your output is just going through tank A and coming out of tank B, then you will get a very good response. Why? Because the tank length is very small. Yeah, you will get a very good output. If your tank length is going increasing, then we are going to have a bit more time delay. If it is passing through both of these tanks, then more and more time delay. Yeah. After this, you are calculating the amplitude ratio. What is the amplitude ratio? Amplitude ratio is basically output divided by input. And already whenever there is some sinusoidal signal, so there is some frequency. Yeah. So based on this frequency and based on this amplitude ratio and based on this phase angle, you are going to plot the Bode plot. Yeah. Bode plot is very important in control system to know the order of the system, to know about the different parameter, how much your system is leading or lagging. So Bode plot is important in these terms. So your ultimate goal would be to draw the Bode plot. Clear?
Okay.
Any problem?
Oh, tadi oh. Kau datang kan?
Bukan main ni.
Sebab dia punya banyak dia.